Let's now look at the language so we can understand the syntax and available objects. So we're looking at the language and syntax of JavaScript. JavaScript, like any language, has a basic syntax that can be learned. The language allows us to create variables, to compare values and to perform calculations and actions on objects, but the objects that are available to us depend on where the code is run. Whether we're writing in an ASP page, or whether we're writing inside a browser or inside the application server as an internal script. Objects that exist in the browser will not exist inside ASP pages. Objects that exist in ASP pages will not exist in an internal script, but the basic syntax is the same. You'll find that the syntax is similar to C and C++. We've got a very important case, which is JavaScript is case sensitive. In this example, we've got keywords being used. Notice that var is lowercase, VAR, not initial capitals, capital V, not all in capitals, var. Notice that if is correctly capitalized here as well. All other variables, function names, etc., have to be then typed with consistent capitalization. So as we look through here, we declared a variable called ID. Notice that there's a function called crm.getContextInfo, which is returning something passed into the ID variable. And right at the bottom line, where we've got response.write, looking across there, you have to see that I've been consistent in the usage of the variable name. So ID in lowercase is not the same as ID in mixed case or ID in capitals. And notice that I've used the idea within one of my methods, crm.getBlock. I've passed in a parameter. Now, parameters which are passed into the database, ultimately to the database, don't need to be case sensitive because the underlying database is not case sensitive. And this is where we sometimes have to be very aware of the fact that JavaScript is case sensitive, but the database isn't. So we need to know where the thing is that we're writing is going to be used. As we write our code, JavaScript ignores white space, so we can use tabs, spaces, and new lines to format our code. Semicolons should be used to terminate statements, but if each statement is on a new line, you can go ahead and you can omit that. But notice how to allow my comments, these things which are describing what I'm doing, what the code is doing, acting as an aid memoir for myself, I've used here commented out lines with the two obliques, // and I've also used the /* and the / to allow me to comment out a range of lines. Have a look at this example. This example is going to be used within the context of custom content firing within the browser. Notice that it's using, declaring three variables, string message 1, string message 2, and string long message. And it's then writing out that variable which has been concatenated out onto the browser. Now I can pick that code up and I can go into CRM, I can go into customization, I can select the company, I can then select a screen and edit the company box long, where I can drop in the code. So if I save that and then view the company where I've written out hello world, you might not see that very carefully, so if I highlight it, you can see that hello world has been written out. And if I go back to this code again, what we understand is that I've declared variables. Now these have what's called identifiers. These are the names, so identifiers are the names of things in JavaScript. Identifiers are used to name variables, keywords, functions, labels, etc. And the rules for legally naming names are much the same in most programming languages. So in JavaScript, the first character must be a letter or an underscore or a $sign. And subsequent characters may be letters, digits, underscores, or dollar signs. One of the things that you're not allowed to do is start naming a variable with a number. So numbers are not allowed as the first character as an identifier. And that's one of the ways in which JavaScript can easily distinguish identifiers from things that are numbers. In our code, like this, variables in JavaScript are untyped. That means they can be of any data type, and they can dynamically change data type. So you see where we've got the initial declaration of a variable called x. It's been as a string of characters, a literal, we've got hello, and then later on, suddenly x has an assignment to it, which is a number. We can define our variables in a number of ways using the var keyword, and you can either declare them separately or you can declare several variables at a time. You can omit the var keyword in top-level code, but it is really needed for local variables that are defined within the context of a function. And I'll be looking at the idea of top-level or global code and then local code in a moment. Well, actually, let's talk about it now. So JavaScript has two scopes, global and local. If a variable is declared outside of a function definition, then it's a global variable. The value is accessible and modifiable throughout any of the script that you're writing. If a variable is declared inside of a function, then that variable is local, and it's created and destroyed every time that the function is executed. It can't be accessed by anything outside of our function. But JavaScript provides different data types to hold different types of values. And within JavaScript, there are two broad types. There's primitives and non-primitives. Now, we've already seen that there's a certain amount of dynamism within the language. That means you don't need to specify the type of variable it is because it is dynamically used by the JavaScript engine. So JavaScript is, instead of a strongly typed language, it is a dynamically typed language. And variables can hold any type of value, such as numbers or strings, and so it can change its type as we do work with it. Now, this is the same Hello World example that we looked at a few slides back. So this is very, very simple, but it's actually been changed to work within an ASP page and not within the idea of a custom content. So the JavaScript is very similar, but although the core syntax is the same, it differs from the custom content example because the code is executed in a different place. And because it's in a different place, it shares the same syntax, but they have to use different objects provided by the environment. Here you can see very clearly the ASP in the browser use different objects when it comes to the writing out. Instead of the document.write, which the browser used, response.write is what the ASP page uses. And notice there's a difference in the capitalization of the objects as well. So different objects will have different rules based on their context in which they're using. Let's have a think about numbers as an example of a type of data. There's no distinction within JavaScript between integers and floating point values. It all uses 64-bit floating point format, and so it's the same type of variable, whether it's x, y, or z. In these examples, x is obviously an integer, y and z are using the idea of a decimal. They are all numbers, and if you try and treat something as a number when it's not, then there is something that is a value that's returned called not a number, nan, N-A-N. You can actually use this sometimes in some useful circumstances when you're testing to see what has been returned by referencing isNan as a function. So it's a test, can test to see whether something is explicitly a number or not. Now let's have a look at some examples use of numbers and how things behave. Notice we've got two variables being declared, x and y. So x is 3, y is 2.5. And then we've got document.write, and because where document.write is writing something else. Now there's two examples. I've got a variable being defined, z plus, which is using an operator plus on the two variables, x and y. See, one line is writing out x plus y equals as a string and then adding in z plus as the variable, and then x plus y, and then seems to be carrying out a set of arithmetic operators on the x and the y. The general rule in JavaScript, if it looks like a number, then it will be treated like a number. But in fact, in the two examples that I've got on the screen here, the two document.write examples will work in different ways. If I go into CRM, you can see here, if I drop this into the custom content box, you can see here that the number in the first example actually has been calculated, treated as a number, and then tied to the string after the calculation was performed. But the second shows that the three variables were just concatenated together. Each was treated as a string. And this is largely down to the fact that what you can see here is the x plus y. If you add a number x to a string, it forms a string. And so you're just adding the 3 and then concatenating the 2.5 to it. Whereas because we carried out the calculation separately using z plus equals x plus y, it was correctly added up to, as we can see here, 5.5. Let's have a look and start thinking some logic examples. And here I want to think about Booleans as a type of value. But Booleans represent two possible values, true or false, used extensively within checks. So many actions look for whether something is true or false. And typically if something is returned that is not explicitly marked as false, then it can be assumed to be true. And this is what's called an implicit Boolean test. So an implicit Boolean test. An example of this is using a method called values. Now, values is something that we're going to meet in the next few lessons, and values is actually a system unique method. So it's something that comes from within the context of CRM, only used in the context of CRM. We're going to meet this in create scripts, and we're going to be accessing this as it allows us to access data passed from the browser to the server. But here there's a code is checking whether or not a field, case SLA ID field, is the service level field, whether it has a value or not. If it does, then it's true, and there's one set of actions to perform. If it doesn't return a value, then it's false, and the code does something else. Now I'm going to discuss statements a little later in this lesson, and I want to explore conditional behavior in slightly more detail as well. But before I get onto that, I want to keep thinking about the types of objects, types of variables, types of structures that we can use, and objects are part of this. And now an object is a compound data type that has properties and methods. Now objects can be built in and provided by the environment that we're using, but we can also create our own objects. So objects are created with a new operator, so we can say chest equals new object, or we can use inbuilt objects based on existing classes. So my date is equal to new date, or my function is equal to new function, and then defining what that function is by passing in parameters. Now we'll be meeting objects and creating our own during a lot of the remaining lessons.